Hi, it's me, Sir Hendrik from Hendrik Academy. In this video, I will explain regarding stationary points or maximum and minimum points. I will discuss how to find a stationary points, whether maximum or minimum points. And afterwards, I will explain how to sketch the graph after we found the maximum or minimum point. We're gonna sketch the graph, particularly for quadratic functions graph. Before I begin this lesson, please click like and subscribe for this video. And afterwards, take your pen, your notebook, your pencil, and also your ruler, and let's study with me till the end of this video. All right. For understanding of this topic, if first derivative equals 0 and second derivative of fx greater than 0, so this coordinate point x comma fx we call as minimum point or minimum turning point. If first derivative of fx equals 0 and second derivative of fx less than 0, so this coordinate point x comma fx we call as maximum point or maximum turning point. Meanwhile, if first derivative of fx equals 0 and second derivative of fx equals 0 as well, so this coordinate point x comma fx we call as point of inflection, not include of minimum point and also not include of maximum point. All right. Now we are going to discuss this problem. Find the stationary point, whether maximum or minimum turning point on the curve y equal to x squared minus 11x plus 12. And afterwards, we are going to sketch this graph. And we could see the stationary point, maximum or minimum. For the first step, we need to find the first derivative with an assumption first derivative equals 0. Why? Because if you want to find the stationary point, you need to find a first derivative, and a design becomes 0. So if first derivative equals 0, it means for x minus 11 equals 0. Why for x minus 11? Because for x minus 11 is first derivative of this function. Okay, so if 4x minus 11 equals 0, it means 4x equal 11. Okay, because negative 11 moves to the right side, becomes positive 11. If for x equal 11, it means x equal 11 over 4 or 2, 3 over 4, 2 3/4. All right. And secondly, we are going to find the second derivative. The second derivative of these functions equal 4, because if first derivative equal 4x minus 11, it means the second derivative equal 4. Yeah, derivative of 11 equals 0. It means second derivative equal 4. 4 is greater than 0. Greater than 0, it means this functions y equal to x squared minus 11x plus 12 has minimum point. Okay, now we are going to find the minimum coordinate point. After you got x equal 11 over 4, this number, okay, submit this x into this equation, y equal to x squared minus 11x plus 12. That means this x will become 11 over 4, and this x as well becomes 11 over 4, such as this one. Based on the calculation, we could find that y equal negative 318. Okay, so it means the minimum coordinate points of this function is 2, 3 over 4, comma, negative 3, 1 over 8. This is the coordinate point. Okay, we need this coordinate point when we will sketching these functions. Right, and the next step, we need to find the intersect between this function and x-axis. To find the intersect between these functions and x-axis through an assumption that y equals 0. If y equals 0, it means these functions would become 2x squared minus 11x plus 12 equals 0. Now we are going to factorizing this equation, and it becomes 2x squared plus 12 here. Now we're going to find two numbers if multiply 24. Why 24? Because 2 times 12 is 24. You need to find two numbers if multiply positive 24, if add becomes negative 11. So those number, if multiply equals 24, are negative 1 and negative 24. Okay, we need to using negative numbers because if add negative 11. All right, and next negative 2 and negative 12, and next negative 3 and negative 8. You already find then those numbers are negative 3 and negative 8. Okay, I'm going to write down here negative 8x and negative 3x. Why negative 8 and negative 3? Because this number, negative 8 and negative 3. And afterwards, I will factorize, becomes 2x times x minus 4. Why x minus 4? Because if 2x times x, it becomes 2x squared. And if 2x times negative 4, it becomes negative 8x, right? And if you already write down x minus 4 here, you have to write down another x minus 4 here, 0. Now, x times how much becomes negative 3x? Must be multiplied by negative 3. Look, if negative 3 times x equal negative 3x, and if negative 3 times negative 4 equal positive 12. All right. The next factorization, the next step of this factorization, it becomes 2x minus 3 multiply x minus 4 equals 0. And there are two possibilities to find x to x minus 3 equals 0, or x minus 4 equals 0. If 2x equals 3, if 2x minus 3 equals 0, it means x equal 3 over 2. And if x minus 4 equals 0, it means x equal 4. So there are two coordinate points through this intersect on x-axis are 3 over 2 comma 0 or 1 a half comma 0 and 4 0. And the next step, we're going to find intersect between this function and y-axis. Because now we already found the intersect between these functions and x-axis. Now we are going to find intersect between these functions and y-axis through an assumption that x equals 0. All right. If x equals 0, it means this function is going to be y equal 2 times 0 squared minus 11 times 0 plus 12. It means y equals 12. And we have another coordinate point, 0, 12. Okay. The next step, we will determine the gradient. The gradient of this function, okay, the gradient of this graph. I'm going to using this table. Okay, recall that the stationary point, the stationary point is 2, 3 over 4. This number. It means in this point, in this x, dy dx gonna be 0 here. Okay, if you submit 2, 3 over 4 into these equations, into this x, the first derivative will become 0. So how about if you submit 1 here, the number below of the stationary point? Okay, if 1, this first derivative becomes 4 times 1 minus 11, and it becomes negative 7. So negative 7 here, and the gradient, it means decreasing because negative. If 0, it means no decrease, no increase. So how about 3? If 3, this first derivative becomes 4 times 3 minus 11, and it becomes 12 minus 11, positive 1. Yeah. If positive, the gradient would be increase. If negative, would be decrease. And if positive, it becomes decrease, increase, I mean. Okay. Like this. Yeah, negative 7, 0, and 1. So now we are going to find the intersect point. First, recall that the intersect point 1.5 or 1.5 comma 0 here. Okay, afterwards 4 comma 0 here. This one, and then 0 comma 12. This one, and then next the gradient will become decrease, and this one the stationary point, and this one increase because positive. So it means before the stationary points 2, 3 or 4, it means 2, 3 over 4 around here. Okay, and we need to find the turning point. Okay, the turning point of this this graph Okay, my turning point, we need to find, we could find the turning point if x equal 3, 2, 3, or 4, the turning point is submit x equal 2, 3, or 4 into this function. And it becomes y equal 2 times 11 over 4 squared minus 11 times 11 over 4. Okay, and then plus 12. Okay, and afterwards we could find a number, turning point, negative 3, 1, 8. These calculations I already discussed on my first slide. Okay, so the turning point is 2, 3 over 4, comma, negative 3, 1, 8. Which one? The turning point, negative 3 is 1, 3, negative 3, 1, 8, around here. Okay. Okay, look, this. The gradient before the stationary point is decreased, so will be decreased from this coordinate point, will be decreased. Okay, until this stationary point, this minimum point, and afterwards, yeah, after this stationary point, this minimum point, the gradient will be increased. From decrease will be increase. Okay, like this. The gradient decrease if negative, and this, the stationary point, and increase positive. Okay, students, if you have any questions, or maybe some of you not understand yet these explanations, you could send me your questions, your message through this email, hendrik.academy21@gmail.com. Thank you for your watching and study with me till the end of this video. See you